Alright, everybody, we're on 5.4, the natural exponential function. Ignore the dryer in the background, hopefully. So, we're dealing with e to the x, f of x equal to e to the x. Remember from math 12, the graph looks like this. It's just a growth curve, an exponential growth curve. A couple properties to remember. The natural log of e to the x. Natural log is log base e. When these bases match, your answer, it simplifies down to just whatever the exponent is. So in this case, x. So if you ever see natural log of e to the x, that equals x. Same thing if it's e to the power of natural log of x. That means e to the power of log base e of x. Again, bases match, just becomes x. So e to the natural log of x is equal to x, and natural log of e to the x is equal to x. Okay, we're going to do a little quick review of the natural logs here. We're solving. So, two simple questions. I have 7 is equal to e to the x plus 1. And I ask you to solve for x. You have two choices. You can natural log both sides. When you do that, natural log of 7, some number. This property, we just set it. It becomes whatever the exponent is. This just becomes x plus 1. So the natural log of 7 minus 1 is equal to x. I don't know what that is. I think it's 0.946 approximately. Okay. The other way you could have done this, if you remember your math 12, is change to exponential form. Where this base moves over and you get log base e of 7 is equal to x plus 1. What's log base e of 7? That's natural log of 7. And then move 1 over and you get the same thing. All right. Okay. Second example. Natural log 2x minus 3 is equal to 5. Solve for x. Well, change to exponential form. So remember, natural log is log base e. You don't have to show all this. I'm just showing it just a review. Change to exponential, so that moves over there, and this moves to an exponent. Yes, 2x minus 3 is equal to e to the 5. And then it's just algebra. Half 3. Divide off the 2. I would just leave it like that. You could punch it in your calculator, and I think it equals approximately 75.707, something close to that. Yeah, so those are just a quick review of solving natural logs. There is some questions. It would be beneficial to do these questions 1 to 15 odd on page 352. And then when you do that, we're going to come back and we're going to do calculus. All right, so derivatives. If I have the natural log of e to the x, we know that is x, right? We just showed it on the previous here, right there. All right, so let's take the derivative. Okay, so if I go, okay, what's the derivative of natural log of e to the x? I'm deriving both sides. And what's the derivative of x with respect to x? That would be 1. Derivative of the natural log is 1 over e to the x times the derivative of that function, u primed over u. So if I multiply e to the x up, I get the derivative of e to the x is equal to e to the x. All right? You can extend that to e to the u. So if your exponent is not some complex function, or it's not a simple function like x. So if I take e to the u and I go, okay, well, e to the u has to equal e to the u, I natural log e to the u, so I natural log both sides. This side, the right side, will simplify to u. I'm not going to simplify the left side. So now I've got natural log of e to the u is equal to u. Do the derivative with respect to x. Again, derivative of natural log is 1 over that function times the derivative of that function. The derivative of u with respect to x is u primed. Multiply the e to the u up, and I'm left with the derivative of e to the u with respect to x is equal to e to the u times u primed. So these are two fairly, it's not really intuitive. The derivative of a function is the function. That seems pretty weird for e to the x. And the derivative of e to the u is just e to the u times whatever the derivative of the exponent is. Okay? The good thing about this is it makes doing derivatives of exponential functions, natural exponential functions, e to the x, very simple. Remember these two rules, you can do every single question. So, first example, what is the derivative of e to the 2x minus 1? Well, we follow this rule here. It's that function, e to the 2x minus 1, times the derivative of the exponent, which is u primed. What's the derivative of 2x minus 1? It's just 2. So the answer is just 2e to the 2x minus 1. Alright, number 2. Derivative e to negative 3 over x. First thing, it's just that function times, then you have to do the derivative of that. So we're going to go off to the side. Negative 3 over x is equal to negative 3x minus 1. So if I'm going to do the derivative of that, I'm going to drop the negative 1 down, take it away, and I'm going to get 3x to the minus 2. So that goes right there. 3x minus 2. Clean it up by dropping that x down. So e to the negative 3 over x over x squared. That's fine. This is fine. This is fine. Since this is a negative exponent, you could just write 3 over x squared e to 3 over x. I don't really care which one you give me, as long as you get it right. Do one more of these. So we'll do the derivative of e, the sine 3x. Okay. Rewrite the function. Multiply by the derivative of the exponent. So this is a chain rule question. What's the derivative of sine? It's cosine. So it's cos 3x times the inside derivative of 3x, which is 3. Now that looks a little ugly, so we'll clean it up. We'll go 3e to sine 3x times cos 3x. So even though the functions look gross, they're actually fairly straightforward to solve. All right. Now, number am I on? Number 4. Find the extrema of f of x is equal to x e to the x. Okay, i.e. find the critical numbers, find the maxes and the mins. So we take the derivative, f prime of x. This is going to be a product rule question, which says the derivative of the first function, x, which is 1, times e to the x, plus the derivative of the second function, e to the x, times the derivative of the exponent, which is 1, times the other function, which is x. So this simplifies to e to the x plus x e to the x. To find our critical numbers, we set it equal to 0. We factor out an e to the x, and I get 1 plus x. So my critical number is x is equal to -1. It's only -1 because nothing that I put in there will make e to the x 0. So I put 0 in, I get 1. So there's no way. This is your only critical number. All right. So we can do a test. -1. Test the left side and the right side. If I put in 0, remember we're putting into the derivative. This is my derivative. So if I put 0, 0's over here. 0 in here, I got 1 plus 0, which is positive, which means we are. If I put in -2, we have 1 over e to the e squared, or e to the -2, which is going to be a positive number. Same with this, but -2 is going to make this negative, so the whole thing becomes negative. You can test that, so it's decreasing. Therefore, -1 is a min. Should write x equal to -1 is a min. X equals -1 is a min. If they're asking for the coordinates, it said find the extrema, so let's find the coordinates. So we need to find the y value, we know the x value. Plug it into the original functions. Is -1 e to the -1, which is just negative e to the -1, or -1 over e. So the min occurs at -1, -1 over e. That's your coordinate, which looks weird, but e is a number, 2.718. Okay. Let's find. Well, we'll use the same function. Number's this. 4, we'll do 5. Purple. Find f double prime for f prime of x, and we'll just use the function up here. E to the x plus x e to the x. So essentially take the derivative again. This is just practice. So f double prime going to be derivative of e to the x. E to the x, that was easy. Derivative of this, well, we just did that up there, but we'll do it again, is 1 times e to the x plus e to the x times x. So we end up with e to the x plus e to the x, which is 2 e to the x plus x e to the x. Change it up, we can pick up e to the x, and we get 2 plus x. That is the second. So if you're looking for points of inflection, possible points of inflection, they didn't ask us this, would be x is equal to -2. And then you'd have to test it. We're not going to do that. All right, last question. And I have to pull up a new sheet here. Bear with me. There we go. Last question is going to be If we have y is equal to x e to the x minus e to the x, find the equation of the tangent line at 1 and 0. Okay. As soon as you see the equation of the tangent line, you know you're doing the derivative, because the derivative gives you the slope. So the derivative of this is the same function we just did. It's minus. So we're going to go product rule. Derivative of x is 1 times e to the x plus derivative of e to the x, which is e to the x, times x minus the derivative of e to the x is e to the x. We have e to the x minus e to the x, but those go away. The derivative is x e to the x. So my slope, m, slope at 1 is y prime evaluated that number, so it's 1 e to the 1, which is just e. My y prime value, which is my slope. Okay? We can write it in y is equal to mx plus b form. I know m, e. I know my x value is 1, my y value is 0. Solve for b. B is equal to negative e. So that's my y-intercept. So the tangent line, and the reason I'm doing this question is because it has lots of e's in it. Do not write the number 2.718, write e, please. Is y is equal to mx plus b. My slope is e. My y-intercept is negative e. There's the equation of the tangent line. E to the x minus e. I think they look kind of cool, but you may disagree. Anyway, hopefully, this wasn't too bad. E to the x isn't too bad, finding the derivative. Excuse me. I would implore you to do questions on page 352. Wow, you're people. 33 to 53 odd, and numbers 57 and 59. Those are the tangent line problem ones. All right. Good luck. Email me if you have any questions.